This is Algebra 1, Part 2, Unit 1, which is Chapter 7, Problem 4, the Got It, on page 420 to 421. A population of insects triples every week. The number of insects is modeled by the expression 5,500 times 3 raised to the W power, where W is the number of weeks after the population was measured. Evaluate the expression for W equals -2, W equals 0, and W equals 1. What does each value of the expression represent in the situation? Okay, so the first thing we're going to do is substitute each of these values in separately for the W. So for W equals -2, we would get 54 times 3 to the -2 power. So the only thing that changes is what we're substituting in. That equals 54. The -2 power makes that 3 a 1/3 squared. So it'd be 1 over 3 squared. It has to move down to the denominator. So 54 times 1 over 3 squared would be 1/9. And 5,400 times 1/9 is 600 insects. So we're going to just do the same thing for the other two values. You're going to substitute. That's not where I was going. You're going to substitute the 0 in. Okay, so if we put 0 in for W, it's 5,400 times 3 to the 0 power. Remember that anything to the 0 power is 1, so it's 5,400 times 1, which means 5,400 insects. And then if we substitute 1 in for W, we get 5,400 times 3 to the first power. Anything to the first power remains the same, so it's 5,400 times 3, which is 16,200 insects. Then there was another question after that said, what does each value of the expression represent in the situation? The 5,400 represents the number of insects in the population when it was first measured. So when they first started their experiment, they went out, counted them, and they got 5,400. The 3 represents the fact that if you look at the very first sentence, it says the population triples every week. So the 3 is because it triples. So we're multiplying by 3. The W is the number of weeks, because you have to multiply by 3 for every week that you're counting. So it'd be times 3 for the first week, times 3 times 3 for the second week, times 3 times 3 times 3, etc. And the answer represents the current insect population after however many weeks. So after 1 week, if you look at our last problem where W was 1, that means after 1 week, there were 16,000 insects.